Hi everybody, I hope this video finds you well. This will serve as the last video on the topic of correlation and regression. What we're going to be doing in this video is a little bit of a sort of side topic in terms of the main flow of correlation and regression. In all the previous videos, we sort of built up this idea that we would want to have two quantitative variables, use the correlation coefficient as a way of measuring the strength between those two variables. Then, if the relationship or the pattern was strong enough, we would try to build a model, the LSR, to sort of understand the relationship between those variables and then use that model to make predictions about the variables. That is the general flow for almost all the stuff that we talked about for correlation and regression. In this last video, though, we're going to talk about just an extra thing that correlation, not the LSR, not regression, not any of that, but just correlation, just that correlation coefficient, that it can be used for. And we're going to talk about this idea of using correlation as a way of measuring agreement. Now, this could be agreement between people, it could be agreement between questions on a survey, political beliefs, whatever. So we're just trying to measure agreement. So, to see this, we're going to do a quick example with some data to get a sense of why the correlation coefficient can be used in this manner. So let's suppose you have 4 film critics who each watch the same 8 movies. So each of them are watching these movies 1 through 8 here. And then they're asked to rate each of these movies on a scale of 1 to 100. And then you get sort of the following data here. So our first reviewer, Ehren here, he gave the first movie like a 91, he gave like the 5th movie a 68, and the last movie he watched, he gave a 97. Now Betty, on the other hand, thought that that first movie should be an 80, the 5th one should be a 95, and that last one should be a 75. And so on and so forth for Cindy and Dave. So our question is, which of these two critics are most in agreement? So which of these two generally sort of agree on which of these 8 movies are the best of the group, the worst of the group, and so on? Now you can imagine that this is sort of a challenging question because we could start by just saying, okay, who has sort of similar scores? Well, you might say, okay, on movie 1, Ehren seems to be pretty close to Dave. So maybe Ehren and Dave agree. But then you can see on movie 2, Ehren gave it a 95 and Dave gave it a 58, so maybe they completely disagree. And that's just looking at the first 2 movies. We'd have to do that for all 8 of them. Also, keep in mind that we have to do all of this relative to how people give these scores. You can sort of see, for example, that Ehren and Dave seem to sort of give very exaggerated scores. Ehren was giving scores up in the 90s and then down here in the 50s and 60s. Whereas Dave was doing the same thing. There's some 90s in there and then there's some 50s, 50, 52, etc. Betty, on the other hand, seems to be one of the nicer reviewers. She generally seems to give lots of scores in the 80s, 90s, or 70s. She doesn't give anything a 50 or a 60. Cindy, on the other hand, seems to be one of the harshest reviewers. Her top scoring movie, movie 3, was only an 80, and she started giving scores in the 30s and 40s. So what we're trying to bring to your attention there is that we have to do this relative to how these people give reviews. For example, for Cindy, an 80 is apparently an awesome review because that's the best of these 8 movies, got an 80. Whereas like somebody like Ehren needs to give like a 96 or a 97 to really like the movie. Or Dave has to give like a 99. So we've got to do this sort of relative to how they give their scores. So the way we're going to do this is we're going to use the correlation coefficient. So the first thing is, to get this sort of ready for our calculator, we're going to put each of these reviewers into their own list. So just out of convenience, we'll put Ehren in L1, Betty in L2, Cindy in L3, and Dave in L4. So we'll put each reviewer in their own list. Then what we're going to do to try to figure out who's in the most agreement is to calculate the correlation coefficient for each pair of reviewers. So let's start off by taking the first pair. Right? The simplest pair to take would be Ehren and Betty. So we'll take A and B, and so we'll do that ln reg AX plus B, and since Ehren and Betty are in list 1 and list 2, we'll make sure we have that set to L1 and L2. And let's see what we would get on our calculator. So if you have your calculator and you're following along, put in Erin's data into L1, Betty into L2, Cindy into L3, Dave into L4, and then go ahead and run that linreg AX plus B on L1 and L2 for Erin and Betty here. And if we do that, so make sure it's set to L1 and L2, which it normally is. Let's see what we would get there. We should get an R value of about negative 0.91. Now, we could record like the A and B and R squared, but we don't need any of that. We just want the correlation coefficient. So what do we see here? Well, we see that that's a strong negative relationship. Remember, a negative relationship means that as one variable goes up, the other goes down. So what that would indicate for these two reviewers is that this would indicate strong disagreement. In other words, when one of them thinks that a movie is better than other movies, the other one actually thinks it's worse. Now, that might be sort of hard to believe because they gave some similar scores. So let's see if we can dissect that a little bit further by actually looking at their individual scores. If you sort of just do it roughly, you can sort of see that Ehren seemed to really like the first three movies and the last one. Well, he gave all those 90s, right? Those all seem to be ones he really liked. And movies 4, 5, 6, and 7 all seem to be ones he sort of disliked. Now, Betty gave 1, 2, and 3 in the 80s. And she gave movie 8 a 75. Those are not bad scores. But keep in mind, those are bad scores for her. Because her scores, these are the lowest she gave. Most of the scores she gave were in the 90s. And all those 90 scores corresponded to when Ehren gave low scores. And our correlation coefficient is detecting that. As Ehren gave movies higher scores for his rating system, Betty generally gave them lower scores, meaning that those two critics disagreed. All right, let's try a different pairing then. Let's see how Ehren and Cindy did. So we'll do linreg AX plus B again. This time we'll want to use L1 and L3. So on your calculator, you'll want to run the same procedure, but you'll want to change that second list, or the Y list, into L3. Or if you have the older calculator, just type it in as L1, L3 here. We'll go ahead and hit calculate, and you should see that you get an R value of about 0.93. All right, well, this time we got a very strong positive relationship, meaning that generally as Ehren rates something higher, so does Cindy. That indicates strong agreement. Let's see if we can actually see that in the data. So again, remember, Ehren seemed to really like the first three and the last one. Well, Cindy gave the first three and the last one 70s and an 80. Those don't necessarily seem like super strong scores, but keep in mind, those are the strongest she ever gave, because the rest of her scores are in the 30s and 40s. So those 70s and that 80 are really good scores for her type of scoring. Notice that her low scores, those 30s and 40s, directly correspond to also the ones that Ehren liked the least. So that's why they are in strong agreement. All right, let's see about how Ehren and Dave compared. So we'll do Ehren and Dave. We'll do that linreg AX plus B. And we'll do L1 and L4. And we'll go ahead and type that into our calculator. So just run that same linreg procedure, but this time switch that second list to L4. And you should get an R value of about 0.03. So what does 0.03 mean? Well, it doesn't mean that it's positive. I mean, it's very close to 0, so it's very, very weak. And it certainly doesn't mean negative. So they don't strongly agree, not like Ehren and Cindy, and they certainly don't strongly disagree like Ehren and Betty. In other words, here, there's really no relationship, meaning that these two don't really agree, nor do they disagree. Let's see why that's the case. Well, we can sort of go just movie by movie. Remember, Ehren seemed to really like the first three and the last one. Well, Dave definitely liked the first one. He definitely liked the third one, but he seemed to really dislike the second one and dislike the eighth one. So out of the 4 movies that Ehren really liked, Dave liked 2 of them and really disliked the other 2. Out of the movies that Ehren really disliked, those 4 down here, well, Dave seemed to agree. 2 of them he gave really bad scores to, but he also really, really liked 2 of them. So apparently there's just no relationship. These two don't really agree on things, nor do they really disagree. There's really just no relationship. All right, we have a couple other pairings to do. We've done all the pairings that involve Ehren, but of course there's other pairings as well. We have to talk about Betty and Cindy, we have to talk about Betty and Dave, and then we also have to talk about Cindy and Dave. So let's go ahead and do those. So let's talk about Betty and Cindy. Notice we don't have to talk about Betty and Ehren because we already know what happens between them, right? And the correlation coefficient can be interchanged. Doesn't matter if we do AB or BA. So we'll skip that one. All right. Let's go ahead and look at the ln reg AX plus B. We're talking about Betty and Cindy, so we want to do L2 and L3 here. Now, maybe we can make a prediction about what this correlation coefficient is going to look like. So let's remember what we already know. Ehren and Betty, they strongly disagree. Ehren and Cindy, they strongly agree. So if we look at Betty and Cindy, well, if Cindy agrees with Ehren and Ehren disagrees with Betty, we would expect Cindy to disagree with Betty as well, because Cindy and Ehren sort of share similar tastes, and we know Ehren and Betty disagree on their tastes. So we expect in our value here that it's going to be negative. So let's see if that's the case. We'll go use our calculator, right? We put in L2 and L3 this time, right? So L2 and then L3, because we're doing Betty and Cindy here. And let's see what our value we get, right? And we get a negative 0.85. And just as anticipated, we get strong disagreement, right? And that's expected because, as we said, right, we know Betty disagrees with Ehren, and we know Ehren agrees with Cindy, so Betty should disagree with Cindy. Okay, what about Dave? Well, Dave seemed to sort of be out on his own when we compared him to Ehren, so it's probably not unlikely that we'll see the same thing with Betty. So let's do Betty and Dave. We do our ln reg AX plus B. Now we'll be doing L2 and L4. So let's go ahead and see that. We'll use that ln reg AX plus B. Make sure you have it as L2 and L4. And we get an R value here that when we round to 2 decimal places should be 0.10. So once again, 0.10, very sort of small, basically shows no relationship. Oh, no relationship. Sorry about that. There we go. A little ugly, but we'll just erase that and make it look a little nicer. That basically indicates no relationship. Okay. Let's see if that makes sense, right? So if we look back at Betty, Betty really liked movies 4 through 7. And Dave disliked 2 of those a lot and liked 2 of those. Betty seemed to not like 1 through 3 and 8. And Dave liked 1 and 3, but he disliked 2 and 8. So they've got some agreement, they've got some disagreement. They basically have no relationship overall. All right, we've got one last sort of pairing to think about, Cindy and Dave, but we can already probably guess what's going to happen here. We know Cindy is in strong agreement with Ehren. Ehren and Dave basically don't agree or disagree, so we don't expect Cindy to agree or disagree either with Dave. So let's go ahead and do that. Let's look at C and D. So we'll do ln reg AX plus B one more time. We'll be doing this for L3 and L4. And if we do that, we run that ln reg AX plus B, L3 and L4. Looks like we should get an R that is about 0.19. Okay, a little bit stronger, but 0.19 is still super small overall. Would not pass the critical value test if we did one of those. So we can again say that there is no relationship here. And that's expected, right? What we've sort of figured out is that despite the fact that all these people give different scores, Ehren and Cindy basically agree about which of these of the 8 movies are sort of the best of the 8 and the worst of the 8. Betty, even though she gives generally high scores overall, disagrees with Ehren and Cindy. And Dave is sort of out there on his own. He doesn't really agree or disagree with either of them. He has some moments where he agrees with some of the people. He has other moments where he disagrees with them. So he's sort of off on his own as a critic here. So this is just a very sort of small scale example of using correlation as a measure of agreement. But you can imagine that this could be very useful in like real life situations, like looking at people's viewing history on something like Netflix or on Amazon Prime Video or something like that, and then trying to find other things they might like based on whether or not they sort of agree or disagree with other people's ratings. So there's a lot of sort of uses of this sort of thing in real life, and I just wanted you guys to sort of see a basic example of it. Notice also it is very different than the other stuff we were doing. It all just relies on looking at those correlation coefficients. No LSR, no making predictions, nothing like that. Just trying to understand if people agree, disagree, or really seem completely unrelated.